Welcome to today's Explainer. I am just absolutely thrilled to have you here because we are about to completely change how you look up at the night sky. Most of the time, when we look up, we tend to imagine the Milky Way as this grand, beautiful, but totally static backdrop, right? Well, today we're going to peel that back and look at the hidden architecture of our home galaxy. We are going to reframe the Milky Way entirely, not as some rigid machine or a vast empty void, but as a deeply dynamic, almost biological-like entity with its very own, fully functioning anatomy.
To get us started, I want you to really think about something for a second. Where does the iron pumping through your veins, right at this very second, actually come from? We so often separate ourselves from the cosmos, like it's out there and we're down here. But I promise you, by the end of our time together today, you're going to understand that the answer to this question lies straight inside the massive, violent, and just absolutely magnificent engines of our home galaxy.
Okay, let's dive into this. The source material for our explainer today actually originates from a beautifully meditative text that describes a gentle voyage through space. But underlying those peaceful words is a staggeringly energetic reality. Just take a look at this quote. The galaxy is a living, breathing system governed by gravity, magnetism, turbulence, and an incredible process of constant renewal. So let's start mapping out this incredible anatomy together.
Section 1. The invisible cosmic web. We'll begin our dissection with what you might call the circulatory system of the Milky Way. When we picture space, we naturally tend to think of it as just that, empty space. But in reality, it is connected by these unseen roots that span vast, truly unimaginable distances, holding the different regions of our galaxy together in this complex, invisible web. The building blocks of this web are what astrophysicists call filaments. These are long, delicate strands made up of neutral hydrogen and ionized plasma. And what's super fascinating is how they're actually formed. They are quite literally woven together by the immense power of magnetic fields and the leftover shockwaves from ancient supernova. So these aren't empty voids at all. They are highly active cosmic highways.
Let's look at what these filaments actually do on a daily basis. They're absolutely crucial for channeling material all the way across the galactic disk. Depending on their state, some of these strands glow faintly when we look at them in radio light, while others remain freezing cold and completely dark to us. But I want you to picture them twisting and branching exactly like enormous invisible tree roots. They're carrying a precious cargo of potential, gas and dust that is quietly drifting to feed the next generation of stars, literally seeding future solar systems with the very ingredients for life.
Section 2. The Great Galactic Fountains. If the filaments are the circulatory system, this next concept is the galaxy's lungs. And honestly, this is perhaps one of the most majestic and massive concepts in all of astrophysics. So the crucial point is how this incredible recycling process actually works. It's a massive loop. Step 1. Violent supernova explosions and unbelievably powerful stellar winds push blazing hot gas upward and straight out of the galactic disk. Step 2. This gas travels way up into towering chimneys in the halo of the galaxy where it eventually loses energy and cools down. Step 3. In a process that takes literally millions of years, it slowly rains back down. And step 4, as it falls, heavy elements forged in the stars are entirely redistributed across brand new regions of space.
I absolutely love this vivid metaphor from our source material. This massive million-year fountain effect stirs the galaxy like a gentle spoon turning soup. It's a perfectly balanced, dynamic motion. Think about it. If this breathing didn't happen, the galactic disk would become far too dense or just entirely stagnant. It's this exact stirring mechanism that spreads the building blocks of planets and ultimately life far and wide.
Section 3. Ancient cities of stars.
Now we're going to journey far, far away from the busy spiral arms of the galactic disk, way out into the cold, distant reaches of the outer halo. This is where we find the memories of the Milky Way, just floating out there in the quiet dark. To even grasp the sheer scale of our galaxy's outer edge, you need to know this number, over 150. That is the number of magnificent spherical cities of stars, known as globular clusters, that orbit our Milky Way right now. They're drifting out there like ancient, glowing lanterns in the dark.
And when I say ancient, I really mean it. Some of these clusters contain hundreds of thousands, sometimes even millions of stars, packed incredibly tight. But look at this age data. Their mutual gravity has kept them bound together for over 12 billion years. 12 billion! That is a time span that is almost impossible for the human mind to fully comprehend.
Now, what's really interesting about this slide is what actually happens inside these densely packed ancient cities. Because they've been around since heavy elements were super rare, they act as literal time capsules of the early universe's chemistry. And because the stars are packed so unbelievably tight, they actually occasionally collide. These rare stellar collisions forge something completely unexpected: blue straggler stars. These are bright, golden blue orbs that appear deceptively young, but they're actually born from the violent wreckage of ancient stellar crashes, and it's all happening on these long, looping orbits high above the rest of the galaxy.
Section 4. The Dark Matter Crown.
Let's zoom out even further to uncover the very bones of the Milky Way. This is the ultimate structure, the unseen architecture that holds everything we've just talked about securely in place. You see, there's this fundamental tension in our galaxy. On one side, we have the fast-spinning visible stars at the outer edges of the Milky Way. Now, based on the laws of physics, they are moving so incredibly fast that they should naturally just fly right off into the void. But they don't. Why? Because of the other side of this tension, the unseen dark matter crown. This is the immense gravitational glue holding the entire visible galaxy together. Its presence is felt in every measured orbit and every gentle warp of the stellar streams. The scale of this crown is just staggering. It envelops the entire visible galaxy and reaches out for hundreds of thousands of light years in every single direction. Whatever dark matter's true nature ultimately turns out to be, we know one thing for absolutely certain. Without it, the Milky Way would have dissolved eons ago into scattered stars just drifting alone in the void. It is the invisible protector that allows our grand, stable home to exist in the first place.
Section 5. Forged in the Stars.
So, we've looked at the massive cosmic web, the breathing fountains, the ancient cities, and the dark matter crown. Now let's bring this immense cosmic scale all the way down to the absolute micro level, to you and your own biology. And this brilliantly illustrates the answer to the question we asked at the very beginning of this explainer. The calcium making up your bones? That was forged in the incredibly dense cores of massive stars that eventually exploded as supernova. The iron carrying oxygen in your blood right now, born from those exact same violent stellar deaths. The carbon that serves as the essential backbone of your DNA, cooked in the intense heat of the hearts of red giants. Every single atom in your body has a billions of years old story.
Here is the incredible timeline of your own existence. Heavy elements are forged deep in the fiery hearts of stars. Upon those stars' deaths, those elements are violently scattered out into molecular clouds, those exact same filaments and fountains we talked about earlier. Those clouds drift, eventually collapsing under gravity to form our sun and our planets. And from that very same star dust, life eventually arises right here on Earth. You are a direct product of the galaxy's life cycle.
Which leaves us with this final, beautiful thought to ponder today. If every single atom inside you shares this incredibly violent, ancient, billions of years old story of stellar evolution, are you really separate from the galaxy at all? Or are you simply a brief, conscious expression of the Milky Way itself, finally waking up just to look back at its own beauty? I really hope this explainer leaves you hungry to learn more about the incredible living system we call home.
Mind-bending astrophysics out there and translate into a dynamic, visual exploration of our cosmic neighborhood. You know, we so often look up at the night sky and just see this static, silent painting of stars. But today, we're going to completely shatter that illusion and see our galaxy for what it truly is.
Okay, let's dive into this. What if the Milky Way isn't just a static backdrop, but a living, breathing ecosystem? Because honestly, that is exactly what the data is telling us. It's definitely not just some random collection of rocks and gas hanging out in a dark void. No way. It is a highly dynamic entity that creates, destroys, and transforms. It literally has a heartbeat, an anatomy, and a lifespan. I promise you, by the end of this explainer, you are never going to look up at the night sky the same way again.
Section 1. The Living Galaxy. Nurseries and Illusions. Let's zoom straight into the chaotic, vibrant regions where our galaxy's incredibly energetic present is literally giving birth to new stars.
Imagine these quiet nurseries, hidden behind thick veils of cosmic dust, in famous regions like the Orion or Carina nebulae. It all starts when massive clouds of gas and dust finally give way and collapse under their own immense gravity. Out of this collapse, protostars form, surrounded by these swirling, completely chaotic disks of material. And this is the very material that will one day become planets, moons, and comets. Then, the newborn star ignites, and some of these young stars shoot out incredibly powerful bipolar jets, literally blasting glowing tunnels right through the surrounding gas. These are stellar birth cries. They light up the dark with shock waves and glowing knots of excited hydrogen, echoing across hundreds of light years just to announce that our galaxy is still actively creating.
But, here's the catch. Not all clouds succeed right away. Drifting silently through the galactic disk are these molecular clouds. These are massive, cold, starless giants, some of them chilling at just a few degrees above absolute zero. Think of them like the galaxy's patient waiting rooms. They are absolutely rich in potential, but they're held back by internal turbulence, magnetic fields, or maybe just a lack of density. So they just float there, holding their breath across cosmic timescales, waiting for a trigger, like say, a shockwave from a distant dying star, to finally push them over the edge into full-blown collapse.
Now, this perfectly illustrates one of the biggest misconceptions we actually have about the Milky Way. The grand illusion is that the spiral arms are these majestic pinwheels of continuously flowing stars, spinning around like a solid object. But the reality? Well, the reality is much more like a cosmic traffic jam. The spiral arms are actually density waves. Think about cars slowing down as they hit a congested patch on the highway. As stars, gas, and dust pass through these denser arm regions, they slow down slightly and just pile up. This pileup compresses those exact molecular clouds we just talked about, which triggers that massive star formation. Bright young stars light up the arm, and then they slowly drift out the other side. So it's not a solid structure at all. It's a flowing wave of compression sculpting beauty out of pure motion.
Section 2. Our safe harbor, the Orion Spur. So amidst all this chaotic creation and cosmic traffic, where exactly do we fit in? Let's transition down from the grand spiral arms to our specific, incredibly sheltered little location in the universe.
The absolutely crucial point here is that our solar system is nestled perfectly in the Orion Spur, which is a minor branch located squarely between the major Sagittarius and Perseus arms. Why does this matter to you and me? Because it's a relatively quiet neighborhood. Being right here means we experience far fewer nearby supernova explosions, much lower overall radiation levels, and incredibly stable conditions spanning billions of years. This calm environment was absolutely vital. It's what allowed the delicate, complex chemistry of life on Earth to evolve without being constantly sterilized or disrupted by cosmic catastrophes. Basically, we have a privileged, safe harbor from which to observe all the chaos out there.
But hey, being in a safe harbor doesn't mean we are just standing still. To put our motion into perspective, think about this massive time frame. 225 to 250 million years. That is roughly how long it takes for our Sun, carrying the Earth and all the other planets along for the ride, to complete just one single orbit around the galactic center.
And as we make that massive orbit, we aren't just moving in a simple flat circle. We're experiencing what scientists call galactic bobbing. The Sun actually bobs up and down through the galactic plane, much like a boat riding over gentle swells in the ocean, swaying up and down through the denser midplane of the disk. So our solar system is essentially riding this giant cosmic carousel. This vertical cycle takes about 60 to 90 million years to complete. Now, some scientists speculate that as we plunge through the denser midplane during this bobbing motion, it might increase our exposure to cosmic rays, or maybe even jostle comets loose, sending them straight toward Earth. Whether or not that directly causes climate shifts or extinction events is still a matter of debate, but it's a really powerful reminder. Even our stable home is constantly moving through a vast, undulating gravitational landscape.
Section 3. Cosmic Wonders, Exotic Wildlife of the Galaxy. All right, let's pick up the pace a bit and take a rapid-fire tour of the galaxy's bizarre extremes. We've seen the nurseries and our quiet neighborhood, but the Milky Way is also jam-packed with some truly extreme objects.
First up, planetary nebulae. When sun-like stars finally reach the end of their lives, they don't always explode violently. Often, they actually meet a really peaceful end, puffing out their outer layers into stunning, glowing shells of gas that look like perfect rings, or even giant cosmic butterflies. Left behind right in the center is a white dwarf, this dense, glowing ember that will slowly cool over billions of years until it eventually becomes a black dwarf, persisting perhaps until the literal end of the universe itself.
Now, what's really interesting about this next slide on pulsars is how we actually use them. These are the rapidly spinning remnants of much larger stars. Imagine an object heavier than our Sun, but the size of a city, spinning hundreds of times every single second. It's wild. They emit these powerful, lighthouse-like beams of radio waves that sweep across the cosmos. And astronomers actually use these incredibly precise pulses as cosmic clocks to test the very limits of Einstein's theories of gravity.
And if you thought pulsars were extreme, wait until you meet the magnetar.
These ultra-dense objects possess magnetic fields so unimaginably powerful that they occasionally experience actual starquakes. Yeah, starquakes. When a magnetar's crust cracks, it unleashes terrifyingly powerful bursts of gamma rays all across the galaxy. These exotic objects perfectly illustrate the absolute extremes of what gravity and quantum mechanics can forge when a really massive star collapses. And honestly, the deeper we look, the more wonders we find. The space between the stars is definitely not empty. It's this interstellar soup containing over 200 identified molecules, where ice-coated dust grains act as tiny little chemical reactors. They're creating prebiotic compounds that might just seed young planets with the very ingredients for life. Threading through all of this is a vast magnetic web that hums with invisible energy, guiding cosmic rays. High above our galactic plane, we have the Fermi bubbles, these massive ghostly wings of gamma-ray-emitting gas that are tens of thousands of light-years tall. And drifting out there in the dark, completely untethered from any star, are billions of rogue planets, carrying untold secrets in the freezing void. What's truly amazing is that spacecraft like Gaia are dynamically mapping all of this right now, completely revolutionizing our understanding of this bustling ecosystem.
Section 4. The Grand Future, the Dance with Andromeda. We've looked at the present, but now we need to look ahead to see how this all builds into the ultimate destiny of our galaxy. The Milky Way has a seriously grand, spectacular future on the horizon.
In about 4.5 billion years, our galaxy is going to collide with our massive neighbor, the Andromeda Galaxy. But it won't be a catastrophic car crash, it's going to be a gravitational dance. The two great spirals will warp each other, pulling out these incredibly long tidal tails of stars. The night sky will literally be ablaze with new bursts of star formation. During the mid-collision, the supermassive black holes at the center of both galaxies will spiral inward and merge, releasing a tremendous wave of gravitational energy. Finally, in the distant future, they'll settle into a single giant elliptical galaxy, which astronomers have nicknamed Milky Way. And our sun? Well, by then, it will likely be a fading red giant or white dwarf, tossed way out into the vast outer halo of this newly formed cosmic island.
But even Milky Way is not the end of the line. That new galaxy will just continue to pull in smaller companions. It will continue to interact with the larger cosmic web. Ultimately, the story of structure in the universe is one of endless assembly, disruption, and rebirth. It is a beautiful cycle that operates on scales of time and space that are almost impossible for the human mind to fully grasp.
Section 5. The Intimate Connection. You are made of stars. Despite this unimaginable scale, and despite the violent collisions and extreme physics we've talked about, there is something deeply, profoundly personal about all of this. I want to slow down for a moment here and really bring this grand astrophysics right back down to you.
The iron in your blood, the calcium in your bones, the water in your cells, all of it once belonged to ancient stars. I really want you to let that sink in for a second. The heavy elements that make up your physical body were forged in the nuclear furnaces of stars that lived and died billions of years ago. Their stellar birth cries, their supernovae, their violent collapses, they all happened so that those specific elements could be scattered across the Orion Spur, eventually coalescing into our Earth and ultimately into you.
The Milky Way is definitely not a cold, distant backdrop. It is your extended home. Every single breath you take connects you to a grand spiral that has been turning for over 13 billion years. Even the invisible dark matter works to cradle everything, holding the entire galaxy together with ancient gravity. You are a fundamental part of something immensely vast and indescribably beautiful. The cosmos is not something to be feared. It is intimate and it is kind. The galaxy turns slowly around you, keeping you safe on this small, quiet planet.
So, as we wrap up this explainer, I want to leave you with this final thought. The light from those spiral arms has traveled across vast, unimaginable distances just to reach your eyes. Its very atoms compose you. If the galaxy is watching over you with such patient, ancient grace, what will you dream of tonight? Sleep deeply, let your mind float among the stars, and never stop wondering about our incredible home.
Keep looking up, keep asking questions, and I'll catch you on the next one.